Today is Thanksgiving, and it seems like a perfect day to be thinking about the absorption and mobilization of fatty acids. That is, today many of you are going to have an incredible dinner that's filled with a lot of fatty treats, maybe some amazing pumpkin pie. So you're going to be taking in dietary fats, which are typically in the form of triacyl glycerols. Now, I've gone ahead and reminded us of the structure of a triacyl glycerol, and that's noted here. We're going to think about once that triacyl glycerol gets to your intestines, and so I'm just going to draw some intestinal cells over here, and we're going to think about how as the, and we'll put one side of the intestinal cell lining there, and on one side over there. And as this triacyl glycerol enters the small intestine, your body will secrete a very important enzyme called pancreatic lipase. So pancreatic lipase is going to go to work in breaking down this triacyl glycerol, but it doesn't do it alone. It requires a colipase. So plus colipase. Colipase allows the pancreatic lipase to maintain its open conformation that's needed in order to hydrolyze the ester linkages within the triacyl glycerol. So pancreatic lipase will break the ester linkage at carbon 3 and also at carbon 1. So those free fatty acids will then get released. So we're seeing the release of 2 FFAs, or the abbreviation there for free fatty acids. But this also then leaves us with a monoacyl glycerol. So after loss of those 2 free fatty acids, we have a monoacyl glycerol, where note that the fatty acyl side chain is maintained at carbon number 2. So carbon number 2 still has its beautiful ester linkage, but of course we've seen the loss of the fatty acids from carbon 1 and 3. So this is very fittingly termed 2-monoacyl glycerol. Mono 1 acyl group, 1 acyl group left on this glycerol backbone. Now, what happens next is perhaps the most beautiful thing in all of metabolism. And that is simply that these free fatty acids and this 2-monoacyl glycerol get emulsified by bile salts. Now, remember that bile salts are the detergents of digestion. So plus bile salts, these bile salts with the free fatty acids and the monoacyl glycerol are going to form a micelle, and we'll make these others in red. So we have a micelle that contains the bile salts and the monoacyl glycerol and the free fatty acids, all emulsified here. And once this is fully formed, it can travel to the intestinal cell lining where they can be taken up. And interestingly enough, once they're inside of the intestinal cell, they are actually re-esterified, which is hilarious. I mean, we go through this whole process to break those ester linkages, and those are then reformed once inside of the intestinal cell. But one of my favorite things to think about is what's happening to the bile salts. So once the monoacyl glycerol and 2 free fatty acids are taken up here into the intestine, well, the bile salts, they will travel all the way down through most of the lower intestine, and then they're taken up, and then they travel through the hepatic portal blood. So you basically recycled in the liver and then sent back to the small intestine. So one of my absolute favorite things to think about when I'm eating a fatty snack is how much I'm giving my bile salts a workout. So today in your Thanksgiving dinner, you can thank your bile salts, and you can just sit back, relax, and say, gosh, I'm sure giving my bile salts a workout today.